Okay, so I am really excited to try to show you how I incorporated math into genetics and genetic inheritance. So rather than look at a Punnett square, which we're all used to seeing, and the alleles, which we're used to seeing, I chose to look at some mathematical equations that I think are super easy to look at and apply and adapt to different scenarios. So I have 4 here, and I apologize for the whiteboard. It was all I could find. But 4 different equations that you can use to just go and apply and find genetic inheritance. And obviously they look pretty simple. They don't look too complex, which makes them great. So here we have dominant trait times dominant trait equals dominant trait 1. And these are alleles, which we're used to seeing. They're just being applied and used differently. So brown eyes, are a dominant trait, and especially if we have 2 brown-eyed parents, we're going to have a brown-eyed baby. And the one comes from, excuse me, I'm sorry, it's not that great to see. The one comes from the fact that there is no recessive trait present, or at least not present in the most, the most recent generations, okay? So it's there, it's evident, it's just overshadowed. So, here we have brown eyes times, let's say, the blue-eyed recessive trait, okay? And this would come more in if you're looking at trying to find a baby of a brown-eyed man and a blue-eyed female. Let's say the brown-eyed man, both of his parents have brown eyes, and the only way for this female to have blue eyes would be if both of her parents had blue eyes, if the blue-eyed gene overshadowed the brown-eyed gene. So if they were to get married, whatever, have a baby, we're going to see a 50-50 chance that it's either going to be a brown-eyed or blue-eyed baby, because the female recessive gene overshadowed another, let's say the brown-eyed gene. The blue-eyed trait for the female is going to be a dominant trait. So in this case, it can go either way for the baby. Now, this is basically the same thing. Really, it's just however you want to choose to look at it. Let's say the female goes here, male goes here, and we're still going to have that 50-50 chance, just the alleles are switched. And then here, we obviously have a recessive trait times a recessive trait equal a recessive trait. Okay, that's all that is. Like I said, for the female, blue eyes times blue eyes equals blue-eyed baby. Okay, so I am going to try to quickly give you a real-life example. So baby Archie, Meghan Markle and Prince Harry's baby, has bluish-green, has brown eyes. But his father has bluish-green eyes, which is a recessive trait. So we have our little a. But Meghan Markle has brown eyes, and the baby has brown eyes. So we're just going to go with a big A to represent the brown being the dominant trait. Okay? And so we're going to look at our equations and see which one matches this. So we got little a times big A, and we know this is the little a times big A equals 1/2 little a plus 1/2 big A equation. And so we just took 2 characteristics, 2 physical characteristics, a scientific fact, and we found a mathematical equation to match it. And I love this more than the Punnett squares, because in Punnett squares you have 4 possible outcomes or results that you can have for the children, the 4 different squares. And this is obviously just 50-50. It's a little bit more narrowed down, and I honestly just think it looks